Hello everyone, thank you so much for listening to this audio, and I want to share with you the idea project that I have in mind, the proposal for this semester and for next one. So my idea is about land use development in areas with volcanic influence across Latin America. I want to do a monitoring process and prediction of land use transformation and in areas susceptible to volcanic hazard between 1990 and 2030 in 3 different locations: Galeras, Colombia; Fuego Volcano; and Popocatépetl in Mexico. All right. So we have 3 research questions. The first research question is trying to see if there is an expansion or reduction of land use development in areas susceptible with volcanic hazard. The second one is to see how is the transformation happening, what is the speed of change, rate of change, and if it's possible to find a common patterns between the different study areas. The third one is possible to identify future patterns of urban transformations in areas susceptible to volcanic hazard in 2030. All right, so continue. Why? Because 76% of the deaths caused by volcanic activity is located in Latin America, because the United Nations has stipulated the urban expansion is growing in a really fast pace in Latin America, and it's predicted that 80% of the population will live in cities, right? Because Latin America is always and will be considered as a global food a place, a region for food production globally, and also because in a radius of 30 kilometers in Central America, there is 20 million people living there. So there is a lot of reason that why it's important to do to monitor and to see the movement of the transformation, but also how we can predict and to see if it's possible to do actions to reduce those conditions and those trends, right? So I select 3 study areas depending of 30 kilometers radius containing urban areas, if there's a hazard map by the government of each country, and if there are recent eruptions that threats to population. All right, so data source, we have Landsat 5, Landsat 8 imagery, hazard maps from the government, road from OpenStreet, DIM from NASA, and protected areas for each of the national parks webpage. So we start with the methodology. We have the methodology divided in 2 classes. One is land use classification, which will be answer the first and the second research question, and the other one is a modeler, which is modeling, will answer the last research question. So the first one is a land use classification. I will use 2 different softwares. One is ArcMap and the other one is Idrisi. I will start doing a land classification, planning to do maximum likelihood classification, and doing accuracy verification to see 1, 2, 3 composites and to see the raster layer that I got from classification for each for the year 1990, to see if it's accurate, and it's established 85% is accuracy. I have checked that in literature in the established that accuracy. I have to check more about it. So I'm going to have the hazard map digitalized and going to use a hazard map. And I'm going to start contrasting those classification and transformations, classification in different years, and to start finding transformation during the period of time. All right. So this part, the second part, is development of the predictive model, right? So in this case, we're going to have development of criteria, and the second is the development of the predictive model. The development of the criteria, it means all the constraints and factors that limitate or push, or makes the urban growth gets bigger, So we have 4 different criteria at this point. Maybe when I'm doing the project, probably is going to change. So we have urban disturbance, how each urban is going to grow using Euclidean distance from roads, how the roads affect slope, and protected areas. which is going to be my constraints. And for the development of predictable model, I'm going to use a land cover from 1990, land cover from 2003. I'm going to use the land change modeler, and going to use the criteria that I identified before. And then I'm going to use a Markov change. All these criteria is going to be adjustable. So machine learning, I'm going to start running the model, and in the model is going to start learning about those conditions and predictions about it, and I'm going to predict the 2017. I'm going to contrast the prediction 17 with the land cover obtaining from 2017, and to adjust the model to see if it's working and it's not. I also read that it's 80% accuracy must to have, so if we got it, we're going to have the land change modeler. I'm going to use the land change modeler again, and I'm going to obtain the prediction of 2030. I'm going to contrast it with the hazard map that I explained before, and I will use our raster calculator or our operation, and then I will get those future areas for urban growth that are going to be in the hazard map. They're going to be a future risk scenarios. So with these expected results, we have land use classification. So I will get a hazard map, I will get the land classification 1913 and 17. In land classification transition between 1917, the data area, rate of change per land use, and percentage of land change per land use. Development of predictable model, which is the second part, would be land use prediction, depth of 2030. That would be a layout about it, and we're gonna get the land change transition between 1930, but also we will find the susceptible urban areas with volcanic hazard in 2030. We're gonna get future urban growth areas and susceptible. For future research ideas, revision land use policies. I will try to use this information for revision land use policies, and I will see how the land policies has been creating also like these conditions and why is happening this, having a historical position of it, and an evaluation and risk assessment of previous and current public policy, urban policy, and land use policy in Latin America. So it's going to be a more general condition. So this is the reference I'm going to show you, and finally this is a preliminary map. It's an AXNEX, and this is one of the results obtained from the last class, in which I did a volcanic risk evaluation. I did some hazard map, how you can see it, and transforming in risk levels. But this is a kind of different project. This is a risk evaluation, however, it's going to include also urban areas and land transformation. I did some land classification in this project as well. I got some vulnerability map, but this is another condition. But this is kind of something that could be related. Okay, thank you so much for listening to this, and have a great night.